Open your book to page 333, and today we're going to learn about the vector product. The vector product is also called a cross product, and because it we present it by A cross B, so it's a cross. Whereas you learned about the scalar product before, and the scalar is a dot product, and this is A dot B. And so this is a scalar because it's just a quantity, not direction. This one is a vector, so it's a direction and a length. And this is equal to A B cosine theta. This is equal to A B sine theta. So when you're doing a cross product, you have to apply the right hand rule. You have to go counterclockwise. So it's A B. So A cross B will give you the normal. So the normal is equal to A cross B, and the length of that is AB sine theta. Okay. Now, the length of the normal is also equal to the area of this parallelogram. So when you're doing a cross product, you're finding the area of the parallelogram. So if you're looking for area of a triangle, you just you do the cross product and you find the area of the parallelogram and you times by 1/2 if you're looking for area of this triangle. Okay. And the significance of the scalar product we did before, right? This is like the shadow or the projection. So if this is A on B, okay, and so you get this projection. And most commonly, this is applied using when you have the two forces and you want to find out how much is the total forces in this direction or in that direction. Okay, so let's go over some examples. Let's go to example 1. Example 1, it says the vector A and B makes an angle of pi/6. So A and B, and the angle is pi/6. And it says the length of A is 5, and the length of B is 8. And you're looking for the area of the parallelogram. Okay. So the area is when you're doing a cross product, and so you got A cross B equal to A B sine theta. Again, we learned this earlier, right, in algebra 2 and in trigonometry. When two sides of a triangles are given, you can find that area, right? Okay, so the area, since the A is already taken, we're going to call it K. So K stands for area. So K is going to be equal to 5 times 6 sine of pi/6. And you work it out. And so now sine of pi/6 is 1/2, right? This is 8. And so work it out. So this is equal to 1/2. So multiply out, you get 20. Okay, let's go to example 2. Example 2, so you got 3 points. You got point A is at 1, 0, -1. Point B is 3, -1, -5. And C is a 4, 2, 0. So these are vertices of a triangle, and you're looking for area of the triangle. So you got point A, B, and C. So you're looking for the area of the triangle. So again, you can use a cross product to do to find the area. So what you want to do is you want to do the AB cross AC. So again, the normal. So the area is the normal, which is also the cross, right? Okay, so first you find AB. So AB is going to be equal to 2I minus J minus 4K, and the vector AC going to be equal to 3i plus 2j plus k. Okay. And so the normal or the area of the parallelogram, so the area equal to 1/2, because it's a triangle, right? 1/2 of AB cross AC. Okay. So AB cross AC is the area of the parallelogram, and triangle is half of the parallelogram. So that's why it times by 1/2. Okay, so area, again, we use K for area because A is already used for the point. Okay, so now this is how you're going to do the cross product. It's a length. Okay, so let's go off to the side. Let's go and do this first. Okay, so you have AB cross AC is equal to, this is how you do the matrix. Okay, you got I, J, and K. And so the vector AB comes first, so you have to put on it. So you have to watch the order. Okay, so AB, so you're going to go 2, -1, -4. And AC is 3, 2, and 1. So this is how you multiply this is how you do the matrix. You copy the next two columns, so you got I, 2, and 3, J, -1 and 2. Okay, and you have to do the diagonals. Okay, so when you go in this way, you add, right? So this is going to equal to -I plus -12j plus 4k. So all this direction would be plus. Then you have to minus, and let's do the I first. Minus 8, -8i, minus the j would be 2j, minus -3k, and so this will equal to, so this becomes plus a, so you end up with a 7i. This one you end up with minus 14j, and this will end up with plus 7k. Okay. So this is A cross B, the AB cross AC. Then you have to find the length of it, right? So this is your normal. So normal equal to that. Now you want to find the length of it, right? The absolute value. So this will equal to square root of 7 squared plus -14 squared plus 7 squared. And then you work it out. So the length of the normal or the cross product is equal to 7 square root of 6. So you have to simplify that. So once you did that, once you did this, you can put it back in here, right? So put this back in here. So you got 7 square root of 6. So the area equal to 7 square root of 6 over 2. Okay, so that would be the area of the triangle. So you want to go off to the side over here to do your cross product, and then after you get your the vector for of the normal, which is the cross product, then you find its length, right? Again, use your Pythagorean theorem, right? So you square that and you take the square root and you simplify that, and then you put it back in here, and that's your area. So again, area of the triangle is 1/2. Now, if you're looking for area of the parallelogram, then that would be it. So again, this is the area for the parallelogram, and times by 1/2 to get the area of a triangle. Okay, let's go to example 3. Okay, so example 3, you got point A is at 2, -1, 3, B at 4, 2, 5, and C at -1, -1, 6. And you have a point D out, so this is a plane, and you have the point D at 5, 4, and 8. So this is what you have. So you have a plane, and you have point A over here, and you got point B and point C. and you have a point out here, D, and so you're looking for the distance, and remember this kind of extends out indefinitely, right? So you're looking for this distance over here. Okay. So you're looking for this distance. The distance, now the distance has to be perpendicular distance, right? You cannot just go at an angle. Okay. So you learned this earlier. Okay, first you have to use the dot product to find the equation for the plane, and then you can use the distance formula, right? So, but this is a different way. You can also use a cross product. So do the cross product. So first, let's go and get the vector AB. So vector AB is equal to 2i plus 3j plus 2k, right? You just go B minus the A. So that you get. Okay, and then you get AC. So vector AC, again you subtract, so you're going to get minus 3i. This minus I is 0. This minus I is plus 3k. Okay, and then what you're going to do is you're going to find the normal. So the normal is equal to AB cross AC. And so this is going to be equal to I, J, K. And the AB is going to be 2, 3, 2. And AC is negative 3, 0. Right? That's not J, so it's 0. And 3. Again, you copy the two more columns. And then you do the diagonal, right? So this is equal to 9i plus negative 6j plus, again, when you go in this direction, you're going to plus and 0, right? And then you go this way, you have to minus, so minus 0 minus 6j minus negative 9k. And so you're going to get 9i minus 12j plus 9k. So this is the normal. Okay, so now to find the distance to that, okay, what you need to do, you have to do the projection. Okay, so when you're doing the projection, this would be your distance. So now you have to use the dot product. Okay, so AD is going to be equal to 3i. You have to minus, right? So AD, so 3i plus 5j plus 5k. Okay, and so you want to project this on N. Okay, so if you redraw your picture, so if you redraw your picture, or you can turn around, you can see that. Okay. So the distance, or you can from here. Another way you can do this is that once you find N, you can find the equation of the plane. You know, you can have the and find the D, and then you can substitute this in here. Again, you have to go back to your previous lesson. Okay. Okay. So we can find this over here. So the distance is going to be equal to. So we have to use the dot product, right? So it's going to be, the distance is going to be equal to the AD dot N. Right? And if you look over here, right, we did this, right, the projection, right? So this is going to be equal to the D dot N over N, right? Okay. So this is going to be equal to, so you're going to multiply, so you're going to get 27 plus negative 60 plus 45 over square root of 81 plus 144 plus 81. So distance is going to be equal to, okay, so you got to work out your math. but it's equal to 12, and if we square root of 306. Okay, so you got to simplify that. Okay, so this is equal to 12 over 3 square root of 34. Cancel. And so this is going to be equal to 4 square root of 34 over 34. So the math is kind of tedious. Okay, and so work it out. So you got distance is going to be equal to 2 square root of 34 over 17. Okay, and that's it. Okay, so again, it's getting pretty complicated, but you have to kind of remember the things you learned, right? So use a cross product to find the normal, and once you find the normal, you can use this to use a dot product to find the projection, which is the length. Okay, so you have over here got a dot product. Okay, so you got to remember a little bit of things you learned from previous lesson. Okay, let's go to example 4. It says find the equation in a symmetric form, the line of intersection of the plane. So you got 2x minus y plus 4z equal to 3. And you got 3x plus y plus z equal to 7. So from here, n1 is going to equal to 2I minus j plus 4k. Okay, so again, this is the normal for this plane, and the n2 is equal to 3I plus j plus k. And you're looking for their intersection. Okay, so again, you can use the cross product to get the equation. Okay, see what happened is this. So if I can imagine that you have a plane. Okay, and so from here, for this plane, you're going to have this n1, and from this plane, you're going to have the n2. So n1 cross n2 will give you this line right over here, right? Again, so from this plane, this is your this is the P1, and this is the plane 2, right? So from this plane 1, you get this normal n1. From this plane 2, you get this normal 2, right? Normal is the direction it's facing. So when you're doing the cross product, you get this line over here, okay, which is the line of intersection, right? That's what you're getting. So that's the reason for doing the cross product. Okay, so n1 cross n2 will equal to this line over here. Again, you do the I, j, and k, and n1 would be 2, -1, 4. N2 is 3, 1, and 1. Okay. So you have to, again, copy the two columns, and you're going to do the diagonal, you work it out. And so you're going to get -5i plus 10j plus 5k. Okay, so once you get your direction numbers, notice that you can divide this by 5 or the -5. Okay? Because what you're doing is that when you divide by 5, right, what you do is you make the length shorten. Okay, you just shorten the length by 1/5. That's what you do when you divide by 5. So divide this by 5. So so divide by 5. You get -I plus 2j plus k. So this will be a direction numbers, right? So it'll be -1, 2, and 1. Okay, and then you have to choose a point. Choose a point that is on the. You have to choose one of the points. So you have to choose a point on this line. And the way to do that is, again, you set one of the variable equal to 0. Okay, so we need to find a point on the line. So to do that, you have to set one of the variable equal to 0. So if you let z equal to 0, then you got 2x minus y equal to 3, and then you got 3x plus y equal to 7. Right? You get these two equations. So you put underneath. So you get 5x equal to 10, so x equal to 2. So again, you're looking for a point on here of that intersection. And you substitute back over here. So again, you have to remember a lot of things you learned from before. Okay, so from here we find the point 2, 1, 0. So now one of the point on the line would be 2, 1, 0. Okay, so from here, so we found the direction and we have this point over here. So you can get x minus 2, y minus 1, and a z. And so this would be your symmetric equation. So again, we did this kind of problem before, but before we did it with a different method. So today, the problem, you have the same type of problem, but you're just solving the problem using the cross product. Okay? So on a test, you can use either technique. You can use the original technique or you can use the cross product technique. But you should practice with your cross product and get used to it.